The basics of algorithms. On a piece of paper, write out, in order, the instructions for making a peanut butter sandwich. Next, compare your written instructions with a neighbor's. Was there anything your steps left out? Did your neighbor have different steps than you? If so, what would you need to have done differently in order for your steps to have been exactly the same? You may have noticed some variance in the instructions you gave compared to your neighbors. Some of these differences might include ingredients used in making the sandwich: peanut butter, jam, jelly, preserves, butter, margarine, etc. Types of bread used: whole wheat, white bread, French bread, croissant. Order of assembling the ingredients, tools used, and serving instructions. What if we wanted to give someone directions that could only be interpreted in one way and would produce the exact same result every time? A sequence of precise, step-by-step instructions that solve a problem or perform a computation is called an algorithm. It is worth noting that algorithms can be written in different ways and still accomplish the same tasks. For example, if you were to take one step forward and one step to the right, you will end up in the same place as if you took one step to the right and then one step forward. On the other hand, algorithms that appear very similar can actually yield very different results, so you must always be careful. Giving someone directions from location A to location B is an example of an algorithm. Algorithms are everywhere, but they are especially important in computer science as they are the foundation of programs. Think of them like recipes. Can you think of some real-life examples of algorithms? Examples can vary, but here are just some algorithms. Instructions on tying your shoelaces, instructions on how to play a game, a baking recipe. When written precisely, these examples will produce the same result no matter when or where they are executed. Algorithms can be created from an idea by combining existing algorithms or by modifying existing algorithms. Therefore, by knowing existing algorithms, you can have an easier time creating new ones. Some common algorithms you might encounter include finding the smallest or largest value in a list of numbers, computing the sum or average of numbers, or determining a robot's path through a maze. Using existing correct algorithms as building blocks for constructing another algorithm has benefits, such as reducing development time, reducing testing, and simplifying the identification of errors. Algorithms can help programmers solve problems. A problem is a task that can or cannot be solved algorithmically. While sorting a list is a problem, sorting a specific list, like a list 52178, is an instance of a problem. A decision problem is a problem that has a yes or no answer. An optimization problem is a problem that has the goal of finding the best answer, for example, finding the shortest path between two locations. Determining an algorithm's efficiency is an important part of computer programming. Efficiency is an estimation of the amount of computational resources used by an algorithm. While an algorithm's efficiency can be determined formally, it can also be informally measured by determining the number of times a statement or group of statements executes. Different algorithms that solve the same problem can have different efficiencies. Algorithms with a polynomial efficiency or slower are said to run in a reasonable amount of time, while algorithms with exponential or factorial efficiencies are said to run in an unreasonable amount of time. When dealing with a problem that cannot be solved in a reasonable amount of time, a heuristic solution can be used. Heuristic programming is an approach to programming where the priority is determining an algorithm that solves a problem in the fastest amount of time. This approach oftentimes trades accuracy, efficiency, and optimality for speed. The idea being that if an algorithm solves the problem, then it is good enough. Examples of common heuristics are using trial and error, common sense, a guesstimate, or following a rule of thumb. When programming, it can be easier to base a new solution off of an old solution that worked in a similar previous scenario.